This is Blaskey, my colleague. My name is Manuel. We are from Columbia Journalism School. And we won't be showing you a lot of code. I don't know if that's good or bad, but hopefully it'll be interesting.
So first I want to know, how many people in this room are journalists? Any journalists? We got a couple. And everyone else is more on the tech end, right? So what we're going to try to do is bring a little bit of like how journalists think about using graph data in an investigative process. That's what we're going to talk about. So spending a little less time on the technical and a little more time on the ideation of the whole thing. We've been working as part of an investigative team at Columbia University for most of the last year as part of the master's program there. Mm-hmm. And we've been trying to integrate using Neo4j into our investigative process. So that's where we start.
So anyway, what we're showing you today, oops, this just jumped on me.
No, this is good. So
I'm sorry, no, you were, so
basically there are two ways to think about how to use Neo, in our opinion. One is kind of what you all think of when you think of the Panama Papers, right? Mm-hmm. They use it as a presentation method. ICIJ has that great offshore leaks thing. You can go in there, you can click on your bubbles, and it's a curated, well done data set that's out for the public to use. And then there's the second way of doing it, which is what we want to talk about today, which is using it internally as part of an investigation, which means that you can have a little bit more flexibility in your matching because eventually you're going to use it as a starting point to then report from, right? So
just a caveat. This is an ongoing investigation, which means it's not public yet, but there's a lot of confidentiality about it, which means we can't really give you much details and this will be the only bad joke of the presentation, we would have to kill you, and we don't really want to do that. So, that being said, the investigation, it's about some particular businessman who has a lot of dealings in his business around the world. And presumably with many people. The theory that we have is that maybe he doesn't really have that many business partners, or maybe it's a really rather small group of questionable individuals. That's what we're trying to get to.
So basically the question is, in all of these holdings, in all of these offshore companies, and all of these like seemingly random business negotiations, has this man partnered essentially with the same small group of individuals? Mm-hmm. And so that's our question that we think that Neo4j can help us find, right? We're looking for paths in between two sets of people, right? But the problem is, we're learning as we go. I don't know why it's cut off, but
because we're learning as we go. Anyway.
But we have phase one, which was like essentially our initial reporting phase, which we're calling the absorbing phase, and phase two, which is the discovery phase. And phase two is sort of like where we are now, today, as we present. The observing phase. Basically, this means that we get to know the subject because we're not the first one to go into this, but we're the first ones who are we're trying to do it in more depth. So what do? Everything. We try to gather information from any part of that has been written about this person. Obviously, the ICIJ has written about me, and OCCRP, some of our colleagues has too. We Google every single clip. We go to Nexit, Lexis, Orbis for his company, Pacer Pacer is the U.S. court document website, and then there's Lunger and many other more that couldn't fit. So that's about the absorbing phase. Trying to do that. In other words, we are starting our own data set from the very scratch, and we are doing it thinking that we are going to use Neo4j, which more or less defines the structure that we'll use. And this is a team effort. We have about a couple of dozen people doing this in our project, which has its own issues, which we'll talk about in a moment. So essentially, the idea is, a lot of times when we work with Neo, you start with a data set and then you query that data set. We don't have a data set, right? We have a question. And so we have to build our data set based on that question. And like Manuel said, we built a data set with 12 reporters essentially reporting this out. And so what people would do is this is just a Google Sheets that we would put together. And you see down here we have all of our different tabs.
we use it as an index to index our reporting, right? So when you find a person that might be related, you put them in the persons tab and you put all their biographical information in. You find an organization, you put it in the organizations tab and you put all their biographical information in. And then you actually manually enter the relationships between the people and the organizations in what you're seeing here, right? So you see at the top like a person, the relationship is employee of this like trademark organization, right? And so we do this thousands and thousands of times with our group of several dozen people. And what it does is it gives you a really, really great reflection of your reporting process, right? So even if you never ever put it into Neo, it's a really good resource. And what it also does is it's perfectly set up to then create a Neo4j instance, right? So we load Neo from here.
So in terms of Neo terminology, these are the relationships and everything else are the nodes. Each one has its own characteristics, which is why they're in separate tabs. One thing that we started doing, though, I don't know if you're familiar, there's this thing called C-maps. If it looks blurry, don't bother taking your glasses. It's supposed to be blurry. Again, we will have to kill you. We tried. So this is not really Neo by far. This is just a visual tool. If you're not familiar with, you actually create things, and this is like what they do in these really cheesy films where they put everything on the wall. Well, this is that, and the advantage also of that is that it actually exports into text these nodes and relationships. So it's kind of symbiotic because there we start understanding it better, and it exports us, and then we can use it in Neo. Little digression.
So
please.
Then we sort of move into like how do we query our data and how do we maximize the usefulness of our Neo instance. And one of the problems is when you build your own data set, right, there are always breaks in your links. Like someone might have known about some sort of relationship and they just didn't enter it. So when you're building your own data, it's about like getting as many possible relationships in there as you can. And so can you go to the next slide? So like there's one problem, right? Like with the Panama Papers, with the offshore leaks, you go into their link curious and you click the bubbles and it's really fun and you watch them go. But when you have this much data and you've tried to make this many relationships, if I were to just keep clicking bubbles, this is an individual who was part of our thing, how would I ever find his connection back to, how would I ever find his relationship within my question of like, how does this person relate to this other person? So we end up needing to use shortest path queries, right, within our data. But those queries are often broken because our data is incomplete. And so it's about like boosting the data. And I think in the next session, the journalism session, Frederick from OCCRP is going to talk about enriching the data set, right? So what they've been able to do with our data as a base is then build out from Orbis, from open corporates to create as many connections as possible. We connect based on phone numbers, we connect based on addresses, and we try to create as many possible links between people and organizations within our data in order to be able to query shortest paths effectively, despite our limited data.
Besides relationships, this was also very useful to understand structures. This is, and again, don't take out your glasses, but this is this is the structure of one of this person's companies. He's here, he owns 1% of all of these LLCs, which own 99% of these corps, which eventually fall into this fund. But this was all in a PDF, this was all in text, and it took me some time to get it out, but finally we understand how it works. Besides the point, but the reason is that if this person gets sued, they can only sue him for what he owns, which is not that, it's this, and this is only 1% of all of that. So, and he's full of these things. So anyway, it's about also learning structures besides the relationships.
This again is just another way that we've used it to look at mortgagers, like mortgages and people that got money to buy different elements within these properties that we were looking at to see if there's connections there. So shortest path, I said, like when clicking bubbles doesn't work, when you wouldn't know which bubble to click on if you wanted to, use a shortest path query. We need to maximize the potential. That's enriching, but we also came up with another technique for,
Excellent.
yeah. So we had like 50,000 PDF documents, right? Nobody can read 50,000 PDF documents, or maybe you guys can, but I can't. And so what we were able to do is we were able to use OCR and then extract entities from those documents, and then we would set a relationship between those entities, as in they appear on the same document. So what does this do for a journalist? This isn't telling us that there's a definite relationship and that this person lent money to this person. This is telling me as a journalist, if you're looking for the shortest path and I see this as part of my shortest path, go check that document, because somewhere in your file of 50,000 documents, each having its own unique ID, these two entities appear in the same place. And so again, it sort of boosts our ability to find these paths in an interesting way and find reporting leads.
Also in the another way that we model it in terms of documents is not making them a relationship, but actually make them some of the nodes. In the way Sarah described, it's more efficient because the document itself is a relationship, but it doesn't give you much detail. This is a little bit more detailed because you know how they are related to that document. So for example, this company is the mortgagee of this document, which is about a property, and this is the mortgagor, if I'm pronouncing it correctly.
Okay,
problems.
so we've talked about some of the problems with this process already. These are things that we're actively working out day by day. So if any of you have suggestions for us, we're open. You want to start?
Name matching. Well, I guess you're all familiar with it. My full name is Jose Manuel Villa Rodriguez. I usually go by Manuel Villa in some documents. Sometimes people arbitrarily just say I'm Jose. Sometimes they put my second last name as the first one, etc. But all of those are me. But if you're investigating me, and I hope you're not, all the documents, you'll get all those documents, and you will know it's the same person, but the database won't, and it actually might not be me. So we've had a lot of trouble with that because, again, we are about almost a couple of dozen of people, and although we're trying to be very clear for the guidelines, etc., we all make mistakes. We forget what we are saying when we're sleeping in the middle of the conference. So this has been a hassle.
Yeah, and another thing is when you're enriching data, right, and you're enriching on a name like Jose Manuel something, like a common name, how do you know that that's actually the same person? And with the Panama Papers, with their data, their link curious sort of says these might be the same people, right? They give this similar names or same name as, I can't remember the relationship they set. With us, we're a little bit less worried about being super careful not to match people that aren't the same people, because this is, again, a starting point for the investigative process, and then we trust our reporters, if you find a shortest path, to then actually go and make sure that that is the same Jose that's showing up. Obviously, you don't want too much overlap, but we're defaulting to the side of like more connections than less because of the problems we've had creating these shortest path queries. The other issue that we've had is querying on a timeline, right? If someone's a CEO of a company at the same time that company did this development project that was owned by so-and-so, that's a significant connection. But if someone was a CEO of a company prior to when they did this development project, and then they left the CEO before, right? Then all of a sudden that relationship, which might appear on your shortest path, isn't actually a relationship at all. They probably have very little connection to that development project. And so we actually haven't really solved this problem beyond just reporting out everything. We haven't written a query that allowed us to query on a timeline, mostly because some of these elements we have a timeline for. We actually put in start date and end date on projects and those kind of things when we're building our master graph, but some things we just don't have a date for. So it's a little bit of a fuzzy science.
The third one?
We talked about incomplete or poorly curated data. I don't know if you all have seen the BuzzFeed data out there. It's the Donald Trump like publicly sourced, crowdsourced data. That was a gold mine for a lot of us, and at the same time a huge problem, right? Because it's just like there was absolutely no real curation to that data, even though they did check every line. But like matching that data onto our data would have been would have been a mess, right? Because you just have poorly curated data that then shows relationships that don't exist, right?
And the very last one is, I was talking with Fredrik, our very kind colleague from OCCRP, and he made me look at something that I hadn't actually thought about, which is journalists have a problem modeling data because they want to model it as a story, not as data, which is more or less when you saw the CMAP, this is really easy to understand because you have people, you have companies, you have a plane maybe, a relationship owner, things like that, but you don't have. It's hard for a journalist at first to see what's that alone. So when you read that map, it's telling you a story. But when you have something related to a telephone, to an address, to something more abstract, how can you have a relationship with a telephone? You probably have the relationship with the person who's on the other side of the telephone, but not the telephone. So for analysis, sometimes when we start doing creating our database of relationships, we have a tendency to take a lot of things out. So that's been an issue. I think we're getting a lot better at it, but just wanted to point out that journalists they have a mindset into that. So please forgive us, and thank you. Do we have time for questions?
Yeah. Does anyone have any questions? Yeah.
Please.
Yes. Thank you for the nice presentation. I have a question. I have a question about how you prepare your data. Do you really do it in Google Docs with your sensible data?
Yeah, so Columbia University has extra protections on their Google server. So the people that have the columbia.edu are the only people that can access our Google Docs. And so we do have an IT team that takes care of our internet security, and they've vetted the process and told us that it is secure. So being not an internet security person, I trust our IT team to tell me if we've done anything that shouldn't be on there. But yes, in this case, because it's through Columbia, we could do it, but we couldn't necessarily share with you, or it would break the security barrier, okay. Right?
Besides the technology security, the fact that Columbia has a deal with Google, which means that if Google gets sued and demanding information, not sued, but if they get requested information from the government, they have to go through Columbia's lawyers, not Google's. So that gives a better control of it.
Legal protection. Any other questions? Yeah.
Michael.
Okay. For matching names, did you also take context into consideration? So if you have John Smith in this context with these connections and John Smith on the other side, then if they share like lots of their context, you can have a higher probability or that these are actually the same person. Do you already do that, or you currently rely on the pure name matching?
So far it's pure name matching, but that is a concept that we've thought about and want to integrate. It's just, it's been a process with a huge investigative team, and nothing moves quickly.
We wish.
We wish it moved faster.
You mentioned you have a team of about 20 or so people. Are they mostly journalists with some technical, or do you have journalists who have technical skills, or are you sort of clearly separating the technical from the journalism?
Well, if I may. So I'm a data enthusiast. I'm not a formally trained in data, but I've been using it for a long time. So I like the data work. It's fun for me. Sarah is really good with investigative documents, and she can give you more details of all the things she's good at, which are a lot. And on the other side, we do have some people in the technical department, a few of the professors there in the Columbia are extremely technical with computer science backgrounds, etc. They help us a lot with the OCR, optical character recognition for PDFs, etc. And also, Columbia has a specialization in data journalism. And a few of the students that have also helped us, and they're really good. So does that answer your question? We're more, there are no defined roles, but yeah, we specialize in stuff.
I must ask this question. The information from your data is very good because you have old data. Mm-hmm. Have you ever thought about the possibility that in future companies and data holders could infiltrate their data with wrong data to make it impossible to explore it with graph technologies, or more difficult to find results?
Right. I think this is actually, it's one of the things that if we had more time I would have talked about. But what's interesting about creating that initial data set based on reporting, right, based on actual journalists going out and finding those relationships and vetting them, is that it creates sort of a thumbprint that you can put onto other bigger data sets, right? And so what you then collect is only the data that connects with the sort of like the world that you've created with your vetted data. So you're basically saying like all of these companies definitely exist and they're definitely doing these things, and we've created 5,000 lines that talk about how they relate in this small world, and then we map that little world onto much bigger data sets. So theoretically that fixes, or that like at least addresses part of the problem of like how do you know that this isn't false data? At least at first, you know that it's matching up to real companies or real people that you have vetted that actually exist. That said, I do think that that's a problem of the future. If I were a company doing this, I would protect myself in that way.
Yeah, it's a risk, definitely a risk. I'm sorry.
So you clean data manually. So as each reporter try to investigate how much is real data or fake.
I'm sorry, once again?
So in this way, you used to clean data as before. For example, if we used analytics, before that, first of all, we clean the data from a lot of noise. But here, because used reporter, journalist who goes there and investigate, so you clean the data manually or from the source, then you build it. So in that way, a possibility of fake is always there.
Yes.
Because even a journalist, he go there and investigate, but they gave them some kind of scenario which convince him, but it, in fact all of it fake.
Yeah.
There is people has capability on cheating. So capability of fake data, it is one of main problem now. With the information technology, as much as get a lot of data, capability to find the real data, it is very hard.
Yes.
It's not easy.
Yes,
And
you're absolutely right.
I think that that's why this is a starting point, right? As a journalist, you're always going to vet, and there are certain like journalistic ethics and standards of what would be considered a fact, right? Like how many different sources need to point to the same thing for you to feel comfortable enough to publish that as a real fact. And so again, within the data, we're looking for pointers. I'm looking for the data to tell me which direction to look, but as the journalist, like I trust my colleagues and I trust myself to at least, to the best of my ability, vet that connection and vet those relationships. But you're right, I mean, journalists go down all the time for accidentally believing a source that has then lied to them. So to some extent, that's a problem within the industry that we always confront, regardless of if we're working with data or not.
And this is really nothing related to technology. What you mentioned has been there for centuries, I suppose, if it involves information. Yes. Yes. But yes, but as there's more information out there, usually it's an arms race. You develop more processing power. So, but yes, I understand your point, and you're right.
Do you also store information like a confidence score or a probability that you trust this data on the relationships, that you say, okay, I don't just store the sources, but I also store how confident I am that this connection actually exists, and then you could add up like confidence scores from different sources and say, okay, if I go beyond this threshold, I say this is a real fact because it was validated by 3 sources or something like that. And if I'm below this threshold, I actually consider this relation, will not consider this relationship in certain queries, for instance. Do you do something like that?
We don't, and I think the reason is because that makes sense to me conceptually why we would do that, but it's still so hard to actually query a shortest path within this data because of the problem of not having a complete data set, that really what we want is to just like bring in all the possible paths, regardless of how likely it is that that's a real relationship or not, and then explore each of those individually, because in this case, we'd rather have more paths than less. But if we ever get to the point where we have too many paths, then let's talk and create that system.
Please come.
Something else for your visualization with many relationships between the company investments and the fund. With something like Epoch, you can create virtual relationships. So you kind of pre-aggregate across like pairs of correlations, and then you create a virtual relationship that already carries the count or like the IDs of these intermediate companies. So for visualization, at least, it might be you get cleaner visualizations out of that if you use something like that. So
Thank you.
Thank you.
I showed it to Friedrich yesterday, so you can
Fred's
also talk
the
about
man.
it.
Fred's
Yeah.
the technical side.
We'll attack him. Thank you.
Great. Anything else?
Coffee, anyone?
Thank you so much.
Thank you.
Thanks so much.
Thank you.